Hello everyone, welcome to Housekeeping Math. Today we will do the integration by substitution. So before applying the formulas directly, we have to modify the function by substituting into new variables. So let's start by looking some questions. Question 1. Integrate 2x plus 9 whole to the power 5 with respect to x. See here the variable is x, so we will substitute this 2x plus 9 to another variable. First of all, let us consider the given integral as I, that is 2x plus 9 whole to the power 5 dx. Now let us substitute this 2x plus 9 to new variable. So let us put 2x plus 9 to new variable, let us say t. Now we have to differentiate this equation both sides with respect to x. So differentiating both sides with respect to x, we will have ddx of 2x is 2 and ddx of 9 is 0. So this will be equal to ddx of t is dt over dx. So here on cross multiplying, I'll get the value of dx as dt by 2. So from here, my integral I will be equal to integration of 2x plus 9 is t. So I will write t to the power 5 and the value of dx is dt over 2. So here instead of this dx, I will substitute with dt by 2. So now my integral has been changed to new variable t. So this equals to, since 1 by 2 is constant, so let us take it outside the integration. So integration of t to the power 5 dt. Now since we have a formula that integration of x to the power n dx equals to x to the power n plus 1 by n plus 1 plus c. So using this formula, here I can write integration of t to the power 5 as t to the power 5 plus 1 over 5 plus 1 plus c. Hence it will be 1 by 2 into t to the power 6 by 6 plus c, and 2 times 6 is 12, and let us put back the value of t, that is 2x plus 9. From here we know t equals to 2x plus 9. So here instead of this t, I'll put back the value of t as 2x plus 9 whole to the power 6 plus c. So this is the required answer. Question 2. Integrate sine 3x dx. So let the integral be I equals to integration of sine 3x dx. Now since we know the integration of sine x dx equals to minus cos x plus c, but instead of that x we have 3x over here. So we will assume this 3x to be another variable t. Now here we have to differentiate both sides with respect to x, then ddx of 3x is simply 3 and ddx of t will be dt over dx. So on cross multiplying, the value of dx equals to dt over 3. Therefore my integral I will be equal to integration of sine, now instead of this 3x I'll write t, and instead of this dx I will be writing dt over 3. So taking out 1 by 3 constant, we will have integration of sine t dt equals to 1 by 3 integration of sine t dt is minus cos t plus constant of integration equals to minus 1 by 3 cos of, let us put back the value of t, that is 3x, so here it will be 3x plus c. Integrate e to the power 1 minus 3x dx. Now again we know that integration of e to the power x dx equals to e to the power x only, but instead of that x we have 1 minus 3x in the power of e. So first of all I equals to e to the power 1 minus 3x dx. Let us put 1 minus 3x as t. Differentiating both sides with respect to x, here we will have d dx of 1 is 0 and d dx of minus 3x will be minus 3, and this equals to d dx of t will be dt over dx, and let us write dx here only because at last we have to cross multiply. So this implies dx equals to dt over minus 3. Therefore, my integral I will be equal to integration of e to the power 1 minus 3x is t, and the value of dx is dt over minus 3. So here dt over minus 3, and let us write that in front, so it will be 1 by minus 3 because it is a constant, and this equals to minus 1 by 3. Now integration of e to the power dt is simply e to the power t only plus c. Now let us put back the value of t from here, that is 1 minus 3x. So my final answer will be 1 by 3 e to the power 1 minus 3x plus c. Question 4. Integrate cosec square of 2x plus 5. This is cosec. First of all, we know that integration of cosec square x dx equals to minus cot x. Let I equals to integration of cosec square 2x plus 5 dx. Assuming 2x plus 5 as t, and differentiating both sides with respect to x, we will have here 2, and ddx of t is dt over dx, and on cross multiplying let us bring dx here only. So the value of dx equals to dt over 2. Therefore my integral I will be integration of cosec square 2x plus 5 is t, so here it will be cosec square t, and the value of dx is dt over 2. It will be dt over 2. Let us bring 1 by 2 outside. So this is directly in formula now, so it will be minus cot t plus c equals to minus 1 by 2 cot of t, and let us put back the value of t again, and it will be 2x plus 5 plus c. Now one thing is to note that this type of questions can be done in a shortcut method also. For that, let us see the question again. The question was integration of cosec square 2x plus 5 dx. Now comparing with the formula, instead of x we had 2x plus 5, and note that 2x plus 5 is a linear polynomial. If there is a linear polynomial, then we can integrate this in a faster way. So what we will do is, we will assume this 2x plus 5 as x only. So we know that integration of cosec square x dx is minus cot x. So here it will be directly minus cot x. But we have to divide this answer with the derivative of 2x plus 5. So the derivative of 2x plus 5 is 2 only. That's why we will divide this with 2, and we will obviously add the constant of integration. Hence the answer comes same. So you can use this method only if there is a linear polynomial inside the function. Let us revisit question number 3. So here you see we had the question integration of e to the power 1 minus 3x and dx. So instead of x there is 1 minus 3x, but this 1 minus 3x is a linear polynomial. So if there is a linear polynomial, we will for a while assume this as x. So integration of e to the power x dx is simply e to the power x only. So it will be e to the power x, but we have to divide this answer with the derivative of 1 minus 3x, and the derivative of 1 minus 3x is minus 3. So that's why we will divide it minus 3 and obviously add the constant of integration. Now again, if you see that the answer is same here. Similarly, in question number 2, we had integration of sine 3x dx. So instead of x, there was 3x, and this 3x is a linear polynomial. So for a while, let us think this 3x as simply x. So integration of sine x dx will be minus cot x, but we have to divide the answer with the derivative of 3x, and the derivative of 3x is 3. So here we will divide with 3 plus c, and you can check the answer. Similarly, in question number 1, we had integration of 2x plus 9 whole to the power 5 dx. So instead of x, there was 2x plus 9, which is a linear polynomial. So for a while, we will assume this as x. So integration of x to the power 5 using the formula will be 2x plus 9 whole to the power 5 plus 1, that is 6, divided by 6. This is the formula which we have to use. But again, we have to divide with the derivative of 2x plus 9. And the derivative of 2x plus 9 is 2. So here we will divide with 2 and add the constant of integration. So it will become 2x plus 9 whole to the power 6 by 12 plus c, which is same as the previous answer. So this you can do only if there is a linear polynomial inside the function. Question 5. Integrate sin x cos x dx. So let I equals to integration of sin x cos x dx. Now here the two functions are getting multiplied, that is sin x and cos x. Now here in this type of questions, we have to look if there's one function whose derivative is there or not. I mean to say, we know that the derivative of sin x is cos x. So we will assume this sin x to be t. So let us put sin x equals to t, and differentiating both sides with respect to x, we will have ddx of sin x is cos x and ddx of t is dt over dx. That dx we will write here only equals to dt. So now if you see that cos x into dx equals to dt, and in the integral we have cos x into dx here. So that means I can replace sin x with t because that I have assumed, and in place of this cos x into dx I can write dt. So my integral will be simply t into dt. I hope you understood. Let me repeat you again. This sin x is t, which we have assumed, that's why I am writing t here, but this cos x into dx is dt from this equation. So instead of that cos x dx I am writing dt over here. And now my integration is simple. So the integration of t is t to the power 1 plus 1, that is square, by 1 plus 1, that is 2, plus c. Now let us put back the value of t, that is sin x. So here it will be sin square x by 2 plus c. So this is how we integrate. Question 6. Integrate cos x square log of x over x dx. So let I equals to integration of cos x square log of x over x dx. Now here we will assume this log x to be t. So let us put log x equals to t. and differentiate both sides with respect to x, then we will have d dx of log x is 1 by x dx equals to dt. Now if you see here, we have dx divided by x, and here also we got dx over x, that is dt. So my integral I will be equal to integration of cos x square, so log x is t, that is cos x square t, and dx over x is dt from this equation. So here I will simply write dt. So the now integral became simple. We know that integration of cos x square x dx is minus cot x, so here it will be minus cot t plus c. Putting back the value of t, then we will have cot of log of x plus c. Question 7. E to the power cos square x into sin 2x dx. So let I equals to integration of e to the power cos square x sin 2x dx. Let us put cos square x as t, and let us differentiate both sides with respect to x. Now differentiating cos square x, we will first get 2 cos x, and again differentiating cos x using chain rule, it will be minus sin x into dx equals to dt. So here this minus 2 sin x cos x dx equals to dt. Now if you see here, this 2 sin x cos x is sin 2x. So here we can write minus sin 2x dx equals to dt, and hence sin 2x dx equals to minus dt. Therefore, I equals to integration of e to the power t, and here from this equation sin 2x into dx is minus dt, which we will substitute here. So instead of sin 2x dx, we will write minus dt, and since that minus is constant, so I will write minus in front of integral, and it will be this much. This implies I equals to minus integration of e to the power dt is e to the power t only with constant, equals to minus e, putting back the value of t, that is cos square x plus c. Question 8. Integrate sec square x over 1 plus tan x. Here if you notice that derivative of 1 plus tan x or derivative of tan x is sec square x, so we will assume this denominator as t. So first let I equals to integration of sec square x over 1 plus tan x dx. So let us put 1 plus tan x as t, and differentiating both sides, d dx of 1 is 0 and d dx of tan x is sec square x, and d dx of t is dt over dx, so it will be dx here and dt here. Therefore my integration I will be equal to, now here if you see, sec square x into dx from this equation is dt, so there it will be dt at numerator divided by 1 plus tan x is t. So integration of dt by t is log of t plus c. Putting back the value of t, we will get 1 plus tan x inside logarithm plus c. Question 9. Integrate sec x dx. Now if you see, in previous video we only learned about integration of sin x and cos x. Now using the method of substitution, we can derive the formula of all trigonometric functions, but out of these 4 I have chosen integration of sec x dx. and its answer is written over here also. So let I equals to integration of sec x dx. Now before assuming anything here, let us multiply and divide with sec x plus tan x divided by sec x plus tan x dx. Then it will be, opening the bracket, it will be sec square x plus sec x tan x whole divided by sec x plus tan x dx. Now if you notice here, at numerator we have sec square x and sec x tan x, which is the derivative of sec x and tan x. So that's why we will assume this denominator to be t. So let us put sec x plus tan x equals to t. Then ddx of sec x is sec x tan x, ddx of tan x is sec square x, and ddx of t is dt over dx. Then it will be dx here and dt over here. Therefore my integral I equals to integration of, now if you see, sec x tan x plus sec square x dx equals to dt, which I have here in the numerator. So therefore in numerator I will only have dt, and in denominator which I have assumed as t. So my integral became dt over t. So it will be log of t plus c, and putting back the value of t, we will have log of sec x plus tan x plus c, and hence the formula which is written over here. So you can derive the formula for cosec x, cot x and tan x in a similar manner. Question 10. Integrate 9x square minus 4x plus 5 over 3x cube minus 2x square plus 5x plus 1. Now if you see the numerator and denominator, the numerator is the derivative of this denominator. So let I equals to integration of 9x square minus 4x plus 5 over 3x cube minus 2x square plus 5x plus 1 dx. So let us put this denominator to be t. So put 3x cube minus 2x square plus 5x plus 1 equals to t. So I have assumed the denominator to be t. Now differentiating both sides with respect to x, we will have 9x square minus 4x plus ddx of 5x is 5 and ddx of 1 is 0, and ddx of t is dt over dx. So that's why dx came here and dt is here. Therefore my integral I will be equal to, since in the numerator we have 9x square minus 4x plus 5 into dx, and which is equal to t from this equation. So my I became integration of dt divided by denominator is t. Now again this is log of t plus c, and putting back the value of t, we will have 3x cube minus 2x square plus 5x plus 1 plus c. So this is the answer. Question 11. Integrate 1 plus tan x over 1 minus tan x. So before assuming anything, here we will write tan x as sin x over cos x, and let us simplify a little bit. Then here it will be cos x plus sin x after taking LCM and adding the fractions, whole divided by cos x minus sin x by cos x dx. So here this cos x and cos x got cancelled. So we will have I as integration of cos x plus sin x divided by cos x minus sin x dx. Now let us assume this denominator to be t. So put cos x minus sin x equals to t, and differentiating with respect to x, we will have ddx of cos x is minus sin x minus ddx of sin x is cos x into dx equals to dt. So this implies, let us take out minus common, then we will have sin x plus cos x into dx equals to dt. So sin x plus cos x into dx equals to minus dt. Therefore, the integral I will be equal to integration of here cos x plus sin x into dx from here is minus dt. So we will write minus at front and dt at numerator divided by the denominator is t. So this equals to minus log of t plus c equals to minus log of replacing t with cos x minus sin x plus c. So this is the answer. Question 12. Integrate x cube over 1 plus x to the power 8. So let I equals to integration of x cube divided by 1 plus x to the power 8 can be written as x to the power 4 whole square dx. Now let us assume this x to the power 4 to be t. So if I put x to the power 4 as t and differentiate both sides, then we will have 4x cube dx equals to dt. So that means x cube into dx will be 1 by 4 into dt or dt by 4. Therefore, my I will be equals to integration of x cube into dx from here is 1 by 4 dt. So here I will write 1 by 4 at front and dt in numerator divided by, but here we have 1 plus x to the power 4 whole square. So it will be 1 plus x to the power 4 is t square. So this equals to, we have one formula, that is integration of dx by 1 plus x square equals to tan inverse of x. So here it will be 1 by 4 tan inverse of t plus c. Putting back the value of t, then we will have 1 by 4 tan inverse of x to the power 4 plus c. Question 13. Integrate x over root over 1 plus x. So let I equals to integration of x by square root of 1 plus x. Let us put this whole denominator to be t. So put square root of 1 plus x equals to t. Now before differentiating, let us square both sides, then here we will have 1 plus x equals to t square on squaring both sides. And from here we can write x equals to t square minus 1. And if I differentiate both sides with respect to x, then ddx of x is 1 equals to ddx of t square will be 2t, and using chain rule it will be dt over dx minus ddx of 1 is 0. And on cross multiplying we will have dx equals to 2t into dt. Therefore, I equals to integration of, instead of this x I will write t square minus 1 from here. So it will be t square minus 1 divided by square root of 1 plus x is t, and instead of this dx I'll write 2t dt. So it will be 2t into dt. So here t and t got cancelled, and let us take out this 2 outside. So I equals to 2 times integration of t square minus 1 dt. So let us separate the integration, then it will be integration of t square dt minus integration of 1 into dt, that is dt. So this equals to 2 into integration of t square dt is t to the power 2 plus 1 3, 2 plus 1 3, minus integration of dt is t plus c. Now let us open the bracket, then here it will be 2 by 3 t cube, and instead of t we have to write square root of 1 plus x cube, because the value of t is square root of 1 plus x, minus here we have to multiply with this 2 also, so it will be 2t, then it will be 2t, and the value of t is square root of 1 plus x plus c. So this is the answer. Question 14. Integrate 1 over x into square root of x to the power 4 plus 1. So let I equals to integration of 1 by x square root of, let us write x to the power 4 as x square whole square plus 1 dx. So here we will assume this x square to be t. So put x square equals to t, and on differentiating we will have 2x dx equals to dt, and hence x into dx equals to dt by 2. Now here if you see, we are getting not only the value of dx but the value of x into dx, but at integral we have only dx here, there is no x here. So what we will do is we will multiply and divide with x here to put the value of x dx. So my I equals to, before substituting, let us multiply and divide with x, then here we will have x by, and since there is already one x here, so here it will be x square square root of x square whole square plus 1 dx. Now let us substitute the values, then I equals to integration of x dx is 1 by 2 dt. So here let me write 1 by 2 at front, and dt in numerator, divided by, since we have assumed x square to be t, so here instead of this x square we will write t, so then it will be t into square root of t square plus 1. Now this is in the formula of sec inverse of t plus c, and let us put back the value of t, so it will be sec inverse of x square plus c. So this much in this video. We will continue more questions based on method of substitution in the next video. So keep practicing more and more questions.